My name's KR Huff. I own my own business, Traction Engineering LLC. I do reverse engineering for big tractors, and I'm from Pendleton, Indiana. Leroy here he has Leroy Machine, and he does a lot, and I mean a lot, of wheel building and also pattern making and machine work for lots of different projects right now. I mean, has for what, 40 years now probably?
Yeah, pretty close.
Yeah, long time. Very, very talented individual. So why do people need new wheels? Sometimes the wheels are missing off of a project. A lot of guys like to accessorize their tractors. Some guys love extensions, some guys don't really care about extensions. So they do take up a lot of space. So that definitely, you got to build a bigger barn most of the time. Extensions are kind of the culmination of a lot of different projects or processes. You need steel parts, you need castings, there's lots of fasteners, lots of rivets. So it goes into a lot of different aspects of machining and fabrication. Here we go with a flat layout. This is what Leroy starts with to design all the whole layout for a wheel. Because you got to match, if you're building an extension, you got to match the wheels so everything bolts on, and you can be able to lay out the plate flat, and then you can get it rolled, and it's a lot easier that way. You want to talk about that?
Yeah, I'll talk about that. A lot of people might not understand how you figure out how long a piece of steel do you need to make a rim. Well, the way I always do it, if you need a wheel, say it's 6 feet in diameter, and you know that piece of steel has to be a 1/2 inch thick or 5/8 of an inch thick, whatever it is. The way I lay it out, I'll make a drawing of the wheel diameter, and then if the piece of steel is a 1/2 inch thick, you step in 1/4 of an inch and you use that diameter, because when you roll that wheel, the metal stretches one way and it shrinks the other. And so that gives you a pretty accurate dimension by using half the thickness.
Neutral axis.
Right. And then you take that dimension and you divide it up, like if you got 8 spokes or whatever, you evenly space the whole spacing out. So anyway, once you've got that figured out, then what I'll do is I'll make a template. And that saves a lot of, number one, time of laying out each individual hole. And I'll make the template so, like, if you got 10 spokes or 8 spokes, whatever, I'll make my template that I only use that much of the wheel, and I'll put all the holes in it. And then on the drawing, or here,
You want to go back?
there should be, I got a hard time seeing it, but there's going to be like a little notch in my template. And I have one laying here that you can look at. And then I only have to measure however many times I got to move that template. And it's a lot less chance that you're going to make a mistake when you lay out all those holes. And so I do have a template here that this is for a case 2040. And you stamp all your holes in there and you drill them while it's flat. It's real miserable to try to drill holes in wheels that's round. And also by doing that, it gives you the opportunity to see if you've made a mistake when you do your layouts. Now I got a drawing up here that shows the layouts to make a set of wheels for a 4072 case that we're working on. I also make a template that when material's being rolled, we can check it and make sure it's getting rolled where we want it. Because you don't have to be off very much on that radius, and when you go to put everything together, it ain't round. So you do a couple things like that, and it saves you a lot of headaches down the road. Here's the castings that we had made for that geyser rim that was up a little earlier.
That was a 24-inch geyser steam engine extension rim, which there was no originals out there to buy. So we reverse engineered from a real wheel and an extension that's a narrower extension, because one of our customers wanted the biggest, baddest wheels he could get. So we put 24-inch wide wheels, and it had a 7/8 inch thick rim.
Yeah, those rims were 7/8 of an inch thick.
That rim is 7/8 of an inch thick. That is one heavy extension rim.
And we did it exactly like the original. You got wedges down in there that help tighten the wheel up and center it. And there you can see the type of castings that we had to make. Now they're made out of ductile, and there was absolutely no machine work to do on them. When we laid that out, we put this radius and everything right on the casting, and we did it in a core box so that you didn't have to have draft. That way when we got that casting, it fit right to the rim. You're ready to rivet it together. Those holes here where it gets riveted are all tapered. So when you put that rivet in there and you press her down, it gets tight. So you're not relying on just the head of the rivet to hold it in place, because that rivet swells up on a taper. The other thing that you don't want to do, it's not a good practice anyway, rivets, if you can't get what you want, you don't want to take a piece of cold rolled or a piece of hot rolled and machine them out. Because what happens, that metal has a grain in it. And when you machine the diameter of that rivet and then you let the head on, you've cut through the grain of that rivet. And it's possible the heads will pop off. A proper rivet is, that head is set on there. They make a die and push them on. You can get rivets, I usually get mine like through JC Rivet Sale or whatever, but like those geysers, they were a special rivet. If I remember right, they had to be like 5.5 inches long, and they had a cone head. I went to Master Bolt in Ohio and they made them. When you get into something like that, you can figure you're going to pay about $5 a rivet to have them made. But that's to do it right. I know some guys will machine them out. You know, they need 1 or 2 rivets, and you might get away with that. But typically you want to use a low carbon steel to make your rivets out of. Those rivets that we used in the geyser were made out of A36 hot rolled. So that's just something to throw out to you. You know, it's not a good idea to machine rivets. Here you can see we're fitting them together. Each one of those lugs is held on by 5 rivets. And I forget exactly how many lugs were on there, but I think it was 28 or 24.
28, because there's 14 spokes.
Yeah, okay. On each wheel. And there was 5 rivets in each wheel, or each lug. And then you got all the rivets in the feet. There was a lot of rivets in them. I actually made a rivet squeeze that has a 100-ton hydraulic cylinder in it. And it works pretty good for that.
Leroy did a video here, 2-3 years ago about building 2040 case extensions. We're going to watch that real quick. Just gives a good brief overview of the process.
Yeah, I came out here, it was winter time, it was snowing. It was a fun time to come out from Pennsylvania, but we did it.
Well, Leroy's built, 7 or 8 sets of these 2040 case extensions, which also fit the 60 case steam engine, the 75 and the 40. So it's got a pretty big, broad usage.
Something else I'll mention is when you do the splice plate, you don't put the holes in the splice plate at the same location you do for the outer rim, because you got that taper coming down, so you got to move the holes closer together on the splice plate. I used to build wheels like that. In fact, Lou Weiss up here, I made a set for his Fairbanks tractor, and we did that. I said, you know, we're going to do something different. We're going to make a press.
Yeah, I hear it. Leroy's got this really sweet, what do you call it? Stand.
It's a stand,
Oh,
you know.
I'm hoping when Leroy retires, he wills it to me, or I can buy it from him.
You've done all right with me. You'll just have it.
You guys make sure you guys write that down.
Yeah. Well, if my son's got to deal with it, it'll go to the scrapyard. But that's an engine base off an 18-horse Stover. Well, you can't give engine bases away, so I said, well, we'll just make a stand out of it.
I've done a lot of hammering rivets, and I've done a lot of squeezing rivets now, and there is no comparison of squeezing versus hammering. There we go.
With a little age, it'll be hard to tell one of these new rims.
So that's just a brief overview. Now we're going to start talking about pattern making. And back in the era of this stuff getting built, there must have been thousands and thousands of pattern makers, because with all the changes tractors got made in that early era, like there's so many different variations on pre-20s tractors that it's really mind-blowing how many different changes had to get made, and then the pattern all had to get changed. And so now we're at a point where we have to start recreating a lot of that. And there's so many different processes. I'm going to let Leroy talk about regular pattern making, and then I'll start talking about some more modern technology.
Okay. Well, what I brought along is I brought the patterns along for a water pump for an early international famous engine. And these pumps didn't do a very good job of pumping. This is what the original paddle wheel or impeller looked like that was in these pumps. And when it's all put together, you can see there's just a whole truckload of clearance in there. And basically it was like just taking a paint paddle and putting it in a 5-gallon bucket and stirring around. It swirls the water a little bit, but it doesn't do anything to move it. And many years ago, Harold Ottaway, who was a well-known collector, made these patterns for making that pump. And somewhere along the line, Dan Christ out in Kansas ended up with the patterns. And I talked to Dan and I said, you know, I'd sure like to get those patterns, because I'm working on a side shaft famous engine that would use one of these pumps. And so Dan and I got together on a deal, and I got the patterns. And what we did is we completely reworked the whole inside of the cores, and we changed it to an impeller. Now they'll pump water.
This is recently.
Yeah. KR here, I got him a impeller that I like the design. He did a plastic model of it, 3D printed it and all. And then we made the pattern to cast these bronze impellers. But to give you a little idea what's involved on this type of thing, here's the body of the main pump. And you're welcome to come up and look at it, pick it up, look at it. But use a rag, because this silver coating that's on there is actually a parting compound that they use to get this pattern to slide out of the sand. So you'll get some of it on your hands if you don't use the rags. But this is the outside basic shape of the body. And then this is a core print. And that's to create the hollow portions of this pump.
It's very important to try to cast the hollow portions in the new casting, so you don't have to machine it. There's a lot of features you cannot get to machine, so it's a dramatic reduction in time.
A good example of that is the water passages here and the curves that they're on. There's just no way to machine that. Now, when you're making this pattern, you've just about got to make a follow block. So when they're ramming this thing up in the sand, that it holds this body square to their mold that they're making. Otherwise, if it's cocked, they can't get it out. So you got the follower block to make. Well, then to make your cores, you got to make these different core boxes. And, well, it does come apart because I just had it apart. They have to pack the sand in there around this thing. And when it's all together and they got the sand in there, they take a straight edge and cut it off. And that'll get laid into one of the impressions that's made from this core print. Now here's the main box to make that. This portion here makes the form of what I showed you was the back side of the core print. Well, then this is your water passages. And there again, they got to put this together, pack it with sand, and then you got this half that you got to do. And then this all goes together, and they got to make sure it's all completely filled with sand. And they use a no-bake sand, so it'll set up and get like concrete. And then they can lay that in there, and you'll get your new casting, which I didn't get it carried over here. But here's your new casting, and it's got all the cavities in there. So now you're ready to machine it. It's a pretty labor-intensive process. And there's a lot of foundries now, this is what they would call a loose pattern. And there's a lot of foundries now that don't even want to look at those because they don't have the people anymore that know how to mold them. They want everything mounted on boards or to what KR is going to show you next, where they do the 3D printed thing.
So on this impeller, Leroy called me one time and was like, hey, I got this impeller, but it's backwards and I want it thicker. So he sent me this sketch and we talked about it a bunch, and I took the impeller and I had it scanned. I got a buddy who's got a 3D scanner. We scanned it, and then you basically have to redraw it in the software. And then since it had to pump the opposite direction, we had it very easy in the software to reverse that. And then we needed it thicker, so we made it thicker. And then we printed a plastic pattern out of ABS plastic, and then Leroy took it to a foundry in Pennsylvania, I'm sure. Mm-hmm. And then they rammed them up, and I think you're going to make 5 or 6 of these, aren't you?
Yeah.
So with 3D printing, it's very useful for prototyping and checking parts and making sure everything's going to fit. Printers are really coming down in price. We got one running up here that's printing a test sample of a part for the project we're going to talk about in the afternoon. This printer here is actually JT's here in the front, and that's what we printed a big, massive amount of parts on for the project we're going to talk about in the afternoon. The part size is really only limited to the print bed, but you can glue the patterns together and do all sorts of different processes to make a bigger pattern. We made a new pinion gear or a drive gear for a Heart Power tractor this last year, and we weren't sure of the tooth profile because the original gear was so worn. So we printed up 3 or 4 of these test samples, and I had made a fixture to go in the bore, and we were checking it against the pinion, so all the tooth mesh. So that's a pretty, I don't know, what those cost $50 or $60 to print probably, if that, but the gear was $1,500 to make, so we didn't want to make the wrong gear. So this is some other samples of 3D printing. So this is what would also be called a loose pattern, because you can send certain foundries just an original part, or I send them I model the part a lot of times and then scale it up so for shrinkage, so we don't have to worry about that anymore. and then they ram up off of just a totally loose part. And I mean, you can do some really good detail. Like this is Harpar font, which is also used on a lot of different stuff. But you can put that right in the model, and you don't have to glue on separate part numbers anymore. So then the next step into mold making is they've learned in the last 20 years how to print sand. And that has really revolutionized pattern making in the last 10 years, because you still have to have a computer model, which still costs money, and then the sand printing is still relatively expensive, but you don't have to do all of this process anymore. You send the foundry that model of that in the computer, and then 6 weeks later it shows up on your doorstep. It has very much revolutionized how pattern making and castings are made. I mean, and this is not just used in antique tractors, obviously. This is used in industry every day. There are hundreds of sand printers now in this country, and it is really changing the way castings are made. 20 years ago, castings, I mean, that was a big deal. If you didn't have a casting, that was a big deal. Now it's one of the easiest things to get done. I mean, it has really changed how restorations can happen. So we'd like to thank you for your time and hope you enjoyed our segment. Questions?
Do they print the core boxes too?
They print the core. Yep, they print that core in then they can just lay it in. They put core prints on the model also, and then they just lay it in there just like traditional pattern making, but there is no pattern anymore. It's all a digital file.
Would that be a wax?
No, it's a green sand. Let me go back. This is a mold for a Harpar tractor. It's for that part, and it's.
But as far as that's a sand Floridan, and that would be in production, would it?
Oh, they're doing it in production, like GM and all them. They're doing it in production.
If there is a video on YouTube, Ferrari is casting all their engine blocks like that.
But they're printing.
Yep, they do the whole thing. It's all sand printed.
Oh, everything.
Water
Absolutely
passages,
everything.
It's all.
It is. I mean, it's all digital. And what my savings on is I don't have to store a pattern in the rest of my life that we may or may not ever use. I mean, it's on my computer and it's out in the cloud, and wherever I'm at, I can get that file to the foundry in 5 minutes. And I don't have to go chase down a pattern anymore. Like, oh, hey, buddy, you got that pattern still? That has significant savings in the long term.
Right now, if you were to go to a pattern shop and you want a pattern made of this, you're probably looking at least $8,000 to $10,000. If you can get it done cheaper than that, I'd be very shocked.
I could have that pattern, including my time modeling that part, in 6 weeks for $3,500 at most. At most.
Now, the one drawback is, if they make a casting and it don't come out, you start all over and recreate that sand mold.
But I've had probably 500 to 800 castings made in the last 5 years this way, and I've had 2 failures. So it's not an issue.
But there is that opportunity.
There is the opportunity. It does happen. So it really has revolutionized castings.
Something else I'll mention where KR was talking about those gears and making the different programs to see if it would work. One thing to keep in mind, back in the day when these things were being made originally, a lot of gears were done in what they call circular pitch, not diametral pitch, which is more what we use. And the reason that was done, the circular pitch, if you go back into like the old machinery's handbooks, there'll be a table in there called Grant's Odonograph. You can make any gear you want in circular pitch with just a compass. And that was done to make it easier for the pattern makers to create these wooden patterns, and you could create these oddball pitches that was sometimes you'll run into on these old tractors. And so you might have a circular pitch gear with 26 teeth, and if you look at that gear in diametral pitch with 26 teeth, there's going to be a vast difference in the diameter of that gear, which changes the center lines to your shafts. And so if you want to recreate a gear like he's done, you got to look at that, because sometimes they're done in circular pitch. And
A lot of times with a gear, we'll scan like a chunk of the gear, and the reverse side is never bad. No one drove in reverse enough to matter. So I'll take that scan data and I'll mirror it along a center line, and then split the circle up into however many number of teeth it has, and then it's real easy just to calculate it out, and then you have the exact profile, because you can go in there and within thousands trace that profile, and you never have a problem. So, anybody else got any questions? Wyndham.
What kind of software do you use to generate your models?
I use Autodesk Inventor. It's second in market share in normal people that can afford it. SolidWorks is above that, but that's what I use. Wyndham.
We did printing for lugs putting on my 34 Huber steam engine. And you can go directly from print right to actually print the whole pattern,
Right.
right?
Yep.
And not even have to deal with, it depends on how many times you're gonna reuse it, because the plastic will.
Right. And it depends on the plastic. Now they're coming out on a lot of the projects. I use nylon and ABS and some of that. And if you do 100% infill on the pattern, it's just like a wood piece. I mean, some of them are impressively hard, and I've never had a failure. And then there's also another material called tough PLA, that's the term for the filament, and it's really tough. JT mentioned that I should mention that probably in the next 10 to 15 years, we'll be going right from file to metal printed part that'll be affordable. Right now, we're not at an affordable point, because that's probably a $8,000 to $10,000 casting to get printed right to metal. But in the next 10 to 15 years, we will print that right to metal for probably $1,000 or less. I have no doubt of that. Because I mean, they do all sorts of crazy materials right now, like stainless and Inconel and some real weird stuff for rocket engines. I mean, they're printing full-size rocket engines right to metal right now, but that's big time, and they can afford it. So, anybody else? We've got about a minute.
Okay, this is going back to old school, but
That's Leroy.
starting out with that flat piece, you got a flat piece of 18, 20 feet laying on the ground. If you got a 6-foot die, you got any videos out there showing rolling that? How do you keep it round?
well, the trick to
I'm
keep
expecting it down, but
the trick to keeping it round is don't try to roll it all one shot.
Yeah,
Run it through the rolls,
work it back and
5-6
forth.
times. And
gradually.
now, like those rims that we showed you there of the 7/8 thick, I actually took them up to a place at Allentown Steel, and they did those. And they don't want the steel any longer than what they actually need as the finished part. Because if you're just doing it where you're using a set of rolls, usually you want that piece of steel to be at least 5-6 inches longer on each end, because it's going to be a flat spot. And then you trim that off when it's rivet or rolled. That place up there, they don't want that.
A lot of new CNC rollers, they self-compensate for that last few inches. And you have to specify in your drawing no flats. Because like if you look at like a Flower City wheel, the last chunk at the joint, it's pretty flat, because they didn't have welding technology, because a lot of times they go in and stitch them and tack them and then roll them again just to get that flat out of there. Like old tractors, they do not have that flat, or they have those flats. So a lot of technology has changed. I mean, you can roll a wheel, an 8-foot wheel, within an 1/8 of an inch in diameter on 1/2-inch plate, no problem.
Yeah, I don't have any trouble at all holding an 1/8 inch on diameter.
So, all right, guys. Well, one more.
For you, cold rolling or hot rolling?
Cold.
Yep.
Yep.
It's always
There's a lot of real good videos on YouTube about rolling stuff. I mean, they roll 8-inch plate every day. I mean, no problems. I mean, you just type in steel rolling on YouTube and it'll pop up with all. Davi's got some real good videos on their rollers.
That place in Allentown that did those, they can roll up to 3 inches thick, a foot wide. Cold. You know, so you ain't gonna throw anything at them that they can't roll, most likely.
All right, one more. Ed's last one. We got to do Ed.
Casting, like a large casting, a gear or something, making it out of a material that will be lost. In other words, the material that suggested was styrofoam or something. Build the sand around that.
Yeah, and then they vet.
Drag the screw holes and everything, and then you put liquid metal in there and it'll burn that away and fill it up.
Yep, they use a mold material that's more like a concrete, and then they burn that foam. Or, I mean, you can do that with PLA plastic too. There's certain PLAs that you can do that.
How would that work out for, say, 1,000-pound gear, like on a master gear on an E-oil?
I mean, if you could find a CNC router that could route that thing out, it'd be no problem. But there's not a lot of foundries doing lost foam anymore. That's kind of a passe thing anymore.
I heard some of them are sending it away and the Chinese do it.
The Chinese are doing castings. It's a pain in the butt, and it'll be wrong. Been there, done it.
Yeah, you won't get what you're expecting.
Hey. All right, guys. Well, I appreciate your time, and I'm glad you guys came out today, and I think we're doing another break, I think. Yes.